All right, in 6.3 to 6.4 part 1, we worked with factoring out a greatest common factor, GCF, factoring out a GCF binomial, and factoring by grouping, all of which aren't too bad, but they're setting us up for factoring trinomials, which is much trickier. Now we're going to start off with the easy ones, and we're going to work our way into the more difficult ones, like usual in algebra. So let's start by looking at objective 1, which is factoring a trinomial with a leading coefficient of 1. Remember, leading coefficient means that the number in front of your highest degree term, which in this case would be x squared right there, is 1. When the leading coefficient is 1, that's a much easier problem than when leading coefficient is not 1, which is going to become later, right, other than 1. So that's much trickier. All right, so let's start off with what we know about when leading coefficient is 1. So consider the product. When you have x plus 3 times x plus 5, we already learned this, that's x squared plus 5x plus 3x plus 15. First, outers, inners, last. Okay? Now, when we combine, these two kind of combine together into like terms, right? And they make 8x. That's why you get 8x right here. All right, so that's 8x. Wonderful. Now, what does that mean? That means that the sum of, sum of 3 and 5, that makes 8. Agreed? Hopefully. Move that over there so you can see it. So the sum of 3 and 5 is 8. Okay, now what about 15? 15 is the product of 3 and 5. That's the way that when we distributed FOIL, that's the way it worked, right? So 15 is the product of 3 and 5. All right? Okay, so that's how that idea is how we're going to do this. We're going to keep in mind that the middle number for that middle term is the sum of two numbers, and then the last number is the product of those same two numbers. That's what we're going to keep in mind as we try to factor. So we're going to look for two numbers that when we multiply, they multiply to 15, but when we add, they add up to 8. That's the plan, at least, as long as the coefficient is 1. When it's not 1, it is much trickier. All right, so let's do it. I need two numbers that multiply to 30. So I need to have a product of 30, but I need them to add up to 17. Okay, so what are some numbers that make 30? So 1 and 30, 2 and 15, 3 and 10, 5 and 6. They're the numbers that multiply to 30. You didn't really have to do all of them, I know, but just bear with me. All right, so if I'm going to add these up, this one would make 31. This would make 17, this would make 13, and this would make 11. And you can see it right there. Ding, ding, ding. That's the one, right? So 17, if I'm going to make 17 for my middle, I need 2 and 15 to be my two numbers. So x squared, hold on. There we go. X squared plus 17x plus 30. That breaks into two parentheses, x plus 2 and x plus 15. And you can always check yourself by foiling. That's why it's so important that you know how to foil, right? Distribute, whichever way you like to say it, right? You can foil this out. X times x is x squared. Outers would be 15x. Inners would be 2x. 15 plus 2x makes 17x. Multiplies 2 times 15 makes 30. There's your lasts. All right, so next one. N squared plus 3n minus 40, right? Okay, so we need two numbers that multiply to negative 40, but they need to add up to positive 3. So, okay, now this is going to be a little bit trickier because we need to multiply to a negative number. So that means one of these is positive and one's negative. So you could do 1 and negative 40. You could do 2 and negative 20. You could do, let's see, 3 doesn't go into 40. What about 4? 4 and negative 10. 5 and negative 8. Let's see where we are there. That's negative 39 if you add those two up. Negative 18 if you add those two up. Negative 6. Negative 3. All right, we're getting there. Almost there, because this is every combination, and then there's a whole other set of combinations which is backwards, right? So what about negative 5, positive 8? Negative 4, positive 10, and so on. But you can kind of see it right here. Do you see how 5 and negative 8 made negative 3? Well, that's it, right? It's just we want positive 3. So this must be the one right here. If we add up negative 5 and positive 8, we're going to get 3. Right? So if you do one batch, you kind of know the other batch, right? So if you do this batch and you get negative 39, you know the other one's going to be positive 39. If you do this one, you know, get negative 18, you know the one's positive 18. This one's negative 6, the other one's positive 6, and so on. Okay? So you can kind of tell what the other batch of those is going to be like. All right, so that means that our answer is negative 5 plus 8. So you go n minus 5 and n plus 8, because n was our variable in this problem. Done. Alrighty then, so we move on. Now, I won't always give you a table. That was just me setting you up for these notes. But for the rest of the problems, there's no table given. You got to kind of make the table on your own or do it in your head. Okay, so let me see. X squared minus x minus 20, right? So I need numbers, and I'm, of course, you can just write these on your paper. That's what you would do, right? So you need a product of negative 20, but you need a sum of negative 1. There's a 1 there because you don't see anything. Okay, so I need numbers that multiply to negative 20. How about 1? Well, it's negative, right? So 1 and negative 20. That would make negative 19. Well, that's no good. 2 and negative 10. Well, that would make negative 8. That's no good either. Don't underline that. Let's see, 3 doesn't go into 20. 4 and negative 5. There it is. 4 and negative 5 makes negative 1. Okay, so this has got to be x plus 4 times x minus 5. The ones where the coefficient, the leading coefficient is 1, that's why it's just plain x squared. When it happens that way, then you just put in the numbers you found and you're done. It's that simple. It's lovely. It's nice when things work out that nicely. All right, let's do it again over here for the next one. So I've got a squared minus 9a minus 36. So I need to multiply to negative 36, but I need to add up to negative 9. All right, let's see here. 1 and negative 36, that would make negative 35. Well, that's not good. 2 and negative 18, that would make negative 16. That's no good again. 3 and negative 12, that makes negative 9. There it is, right there. So you just keep going. And if you can't see what I'm doing, I'm starting at 1 and working my way up. I go 1 goes into that, 2 goes into that, 3 goes into that. If 3 wouldn't have worked, I would have gone to 4. 5 doesn't divide into 36, so I would have skipped that one, and then 6. So I would have gone 4, negative 9, then I would have gone 6, negative 6. And then I would check all of these, right? Once you hit the one where they're even, like 6 and 6, then everything after that is the backwards of what you already found. So, but we've got it. It's a squared minus 9a minus 36. That's equal to, and now you're going to need an a in both places, right? You have to have 1 plus and 1 minus. That's how you're going to get the minus 36 that you need. And then I think it was plus 3 minus 12 was what we came up with. And there you go. Now, some students, because of the way they learned it, they just kind of see it. You just kind of look at 36 and kind of run through these in your head, and you can kind of figure out, oh, that's the one because that's the one you think of. If that's the case for you, that's fine, right? If you're the kind of student that can do this in your head, more power to you. I'm the same way. I do it in my head as well. However, for your notes, you kind of want to write more down because you want a technique that's going to be based on more than just kind of your instincts, right? So we're trying to learn a method here that'll work even if we can't get a good sense of what the numbers should be. And this technique will work for us like that. All right, so I'm just highlighting the combos that worked for our later reference. Okay, so in this one, I need to get a product of 8, but I need to add up to 9. And that's kind of obvious on this one. This one's 1 and 8, right? Because 1 times 8 makes 9. So there it is. I can just delete these 2 rows. And again, if you see that off the bat, so be it, right? That's perfect. That's exactly what we want. We want you to be able to factor quickly like that in your head. But if you can't see it, you need a way to find it even without being able to kind of envision it, right? So W plus 1 times W plus 8. In case you're wondering, it doesn't actually matter which order I put those two in. I could have said w plus 8, just FYI here. I could also say w plus 8 times w plus 1. That's just as valid. Okay? It doesn't really matter which direction you go in. Okay? And that's true of all of these. I've just written one of them down, but there's always another combo, which is the same numbers, but switch. So you could say, like, instead of x plus 4, x minus 5, you could say x minus 5, x plus 4. Like that. And it's fine. It doesn't make any difference. All right? Okie dokie. Let's get down to this one. Uh-oh. Well, this is no good. I don't like the order of that at all. I want my x squared to be in front. He's my highest power, my leading term, if you will. So I'm going to write x squared plus 19x minus 66. Let me see if that's right. Yep, that's right. So I'm going to rearrange. I better make a note to myself. Rearrange. All right, so I've rearranged it. That's better. Now I need numbers that multiply to negative 66, ooh, but add up to 19. Well, that's all right. 66 isn't going to be too bad. So we'll see here. 66, but they got to add up to positive 19 here. Okay, so 1 and negative 66, that would make negative 65. 2 and negative 33, that would make negative 31. So that's not good. And then 3 and negative 22, that would make negative 19. Oh, there, it's almost there. So what must work is negative 3 and positive 22. That would make positive 19. That's the one we want. So that's the one that I should highlight yellow. Hold on. And then these should not be, because they're not right. Cool. All right, so that means that I want x minus 3 times x plus 22. Or if you like, you could say x plus 22 times x minus 3. That's okay as well. All right, last two. Let's see here. So I've got a squared minus 10a plus 21. So I need the product to be positive 21, but I need the sum to be minus 10. Okay, so let's see. What goes into 21? 1 and negative 21. That would make negative 20. That's no good. 3 and negative 7. That would make, oh, it's positive 21. Whoops, my fault. So it's positive, sorry, positive 21. That would be positive, positive. So that makes 22, sorry, 22. And then this makes 10. Oh, okay, that's close. That's 10. So what if I made them both negative? If I made negative 3 and negative 7, that would make negative 10. So they would multiply to positive 21, but they would add up to negative 10, right? Okay, so there's the one. So I'm going to make this a squared minus 10ab plus 21b squared plus 21. So that's equal to a minus 3b. You got to put the b in there to get the b squared in the back like you want. And then a minus 7b. Right? That'll get you minus 3 and minus 7, just like we said. But then it'll have a plus 21b squared for that back number. Okay, now let's look at the last one. We got to make a product of negative 90. We got to add up to negative 9. Oh, this might take a while. Okay, so 1 and negative 90. That would make negative 89. No good. 2 and negative 45. That would make negative 43. No good. 3 and negative 30. That would make negative 27. 4 and negative... Oh, no, I don't think that works. 4 doesn't go into... Oh, no, yes, it does. 4 goes into 90... Oh, 22.5 times. No, that's not going to work. All right, so 4 is out. 5 and negative 18, that makes negative 13. 6 and negative 15, that makes negative 9. There it is. We found it. It just took a while. So you just kind of keep working your way up until you find the numbers. Once you pass each other, then you know you've gone too far, right? So, okay, so this is m plus 6 times m minus 15. Oops, why do I keep forgetting to box that? There we go. All right, we're all done with the coefficient equal to 1, the leading coefficient 1, and we'll come back for harder ones when it's not 1.